So we've talked so far about how to simplify radicals, how to add them, subtract them, multiply them, divide them, and solve equations that have radicals in them. Now we're moving on to a different topic, which is connected, but sort of a side quest, if you will. So again, a reminder of a couple of motivating questions. First of all, what does it mean exactly when we find the square root of a number? So if, for instance, we have to find the square root of 25, we say that it's 5 because 5 times 5 is 25. That means the square root of 25 is a number that we must multiply by itself in order to get the radicand. So if we're looking for the square root of 36, we need to find a number that we can multiply by itself, and that the key part is by itself. It's got to be identical to the thing that you're picking. This would be 6 because 6 times 6 is 36. The square root of 15 is some strange decimal number, which I don't have memorized, but it's going to be something close to 4 because the square root of 16 is 4. So the square root of 15 is going to be a shade under that, but the square root of 15 isn't a whole number like 5 or 6. It's a decimal number between 3 and 4, but because we cannot simplify it, we just leave square root of 15 as square root of 15. It does exist. We can plug it into a calculator and find it, but it's not terribly useful to us to just, carry a calculator everywhere. So square root of 15 can just stay as square root of 15. Now the problem occurs when, actually one more. Square root of 0 is, well, 0, because 0 times 0 is just 0. So we can multiply 0 by itself to get the radicand 0. The problem occurs when we have negative numbers inside the radical. So you might be inclined to say, well, maybe negative 5 works because there's a negative inside. Well, the issue is that negative 5 times negative 5 gives us positive 25. What we need is negative 25. Now, oftentimes, a common suggestion here is, well, okay, make one of them positive, make one of them negative, and then voila, you get negative 25. Issue here is that you're not multiplying something by itself. So you are finding factors of negative 25 because negative 5 times 5 is indeed negative 25. But negative 5 is not the square root of negative 25 because we cannot multiply negative 5 by itself to get negative 25 as the answer. Similarly, if we have square root of negative 36, well, this turns into an issue. Well, actually, this is incorrect. You might say negative 6. That would be incorrect because negative 6 times negative 6 is positive 36. So hopefully you can see that there's no one number that you can multiply by itself being the key part, to get negative 36 or negative 25 as the answer, even though I can find the square root of 25 and 36 with no issues. So hopefully this answers somewhat the second motivating question, which is, can we find the square roots of all numbers? Now, this isn't a proof, but what we can say so far is we can find the square root of positive numbers and 0. But hopefully from this example, or these examples, you can see that whenever we try to find the square root of a negative number, we're not able to get an answer, at least not until yet. The third motivating question, which is how many types of numbers there are, is something we'll answer at the start of class whenever we discuss this specific topic. In the next couple of videos, you'll see examples of how to deal with numbers that get created whenever we try to take the square roots of negative numbers. We'll see you soon.